Let us divide real numbers into different types of numbers. Okay, so the starting is real numbers. We have something called real numbers. Usually we denote real numbers by the letter R. Okay, now real numbers we will divide into two sections. That is rational numbers and irrational numbers. Okay. Now, rational numbers are generally denoted by the letter Q and irrational numbers are denoted by the letter Q dash. Can you give me examples of rational number? You have learned last time. Yeah.
1 by 5.
Yeah, 1 is a rational number. 1 is a rational number, yes. Then
15.
we can say, yes. 15 is a rational number, negative numbers, negative 8, all these are rational numbers. What about irrational numbers?
Root 3?
Yes.
Root 5.
Root 5. Root 5, yes.
Root 11.
Root 11, all these are
Pi.
irrational numbers. Yeah, pi is also irrational number. So these are all irrational numbers. Now, under rational numbers, we have got many other subdivisions. Just that irrational numbers, we stop there. We are not going ahead with. We don't need to learn further more subdivisions of irrational numbers. So under rational numbers comes, what all are coming? Integers and non-integral rationals. Non-integers or non-integral rationals. What are they? Okay, by the way, integers, how do you represent integers? With what letter? With which letter do you represent integers?
Z.
Z, yes. It is Z or I. Both the letters are used to denote this. So we have got integers and non-integral rational numbers, okay? So here, non-integral rational numbers means what? It can be minus 5 by 8, then 8 by 15. All these are non-integral rational numbers. What is the meaning of integers? What do you mean by integers? Integers means. Can you tell me?
Numbers that are both negative and positive.
And 0, right?
Yes,
so,
ma'am. Negative, positive, and 0.
Yes, so minus 2, minus 1, 0, then 1, 2, etc. 2. So these are called integers. Now, integers, you are going to divide it as how? We have negative integers. We have negative integers. We have got positive integers. And we have 0 coming here, right? We have negative integers, positive integers, and 0 coming here. What is a positive integer? What 1, 2, 3, 4, etc. What is it called?
Natural numbers.
Yes, they are natural numbers. So these are natural numbers. So these are represented by the symbol n. Natural numbers are represented by the symbol n. Now, what is 0 and natural number? 0 plus natural
Whole numbers.
Whole numbers, yes. So these are called whole numbers. Okay, whole numbers are denoted by the symbol W. Okay, so these are the different numbers that we have studied all this while. So we will continue with rational numbers and irrational number in this chapter. What is the definition that you have studied about rational numbers?
Ma'am, it should be represented in, again, a number should be represented in P by Q form where...
yes, where?
Ma'am,
P and Q are integers.
Yeah.
And?
Q is not equal to 0.
Yes, exactly. So Q is not equal to 0 is an important point. So you can say any number that can be represented in the form of P by Q, where P and Q are integers and Q not equal to 0. That is a rational number. This is first point. a rational number is generally when you divide a rational number, you will get, say for example, 18 by 4 is a rational number, right? Now 18 by 4, when you divide, what is the answer that you are getting?
4.5.
4.5.
4.5, right? So here, what happens is you have a decimal number. It is 4.5 is a decimal number, but this decimal part is stopping, right? It is terminating after one digit. But when you take another number, say 10 divided by 3, 10.3 bar or 3.33333, like that, it is keeping on repeating. So what my point is, the a rational number, it can be a terminating decimal. Okay, it can be a terminating. This is terminating. It can be a terminating decimal, or it can be a non-terminating. This is non-terminating. Non-terminating and repeating decimal. Understood? So what is repeating here? In this case, 3 is repeating. So a rational number can be of, one is you are getting a whole number, right? 4.0 or 3.0. That, I mean, when you divide 16 by 4, 16 by 4, you get 4. It can, that's a 4 is a rational number. That's one thing. Another thing is 4.5, where the decimal part is you're terminating. It gets terminated. Third type or third thing is non-terminating repeating decimal. How will you know a number is terminating or not? Okay, so for this purpose, what you need to do is, you have, say for example, I have 18 by 4. I am taking this example. We all know that 18 by 4 is a terminating decimal. So I'm taking the example of 18 by 4. If I am able to express the denominator, what is the denominator? This one. Denominator in the form 2 to the power m into 5 to the power n, then it is a terminating decimal. If q can be represented in the form of 2 to the power m into 5 to the power n, then it is a, which is a terminating decimal? 18 by 4 is a terminating decimal. Same example, 4. How can I express 4? 4 is 2 into
2
2,
to the
right?
power 2 into 5 to the power 0. No.
Yes, 2 to the power 2, 5 to the power 0. So I can represent 4 as, 4 can be represented in the form of 2 to the power 2 into 5 to the power 0. So it is possible. It is a terminating decimal. Got it? Now let me take the second example. Which was my second example? 10 by 3. 10 by 3. So 3, can I express 3 in the form of 2 to the power m, 2 to the power m into 5 to the power n? Here, what I have is 2 to the power 0 into 3 to the power 1 into 5 to the power 0. I have an extra 3 coming in. When I have an extra 3 coming in, or extra any digit other than 2 and 5, then it is a non-terminating repeating decimal. 10 by 3 is a non-terminating repeating decimal. Okay, so you have to remember this. If it is 2 to the power m, if the denominator can be expressed in the form of 2 to the power m into 5 to the power n, then it is a terminating decimal. It will stop. And if otherwise, it is going to be a non-terminating repeating decimal. Question is, without actual division, show that each of the following rational number is a terminating decimal. Express each in the decimal. First question is 31 divided by 2 to the power 2 into 5 to the power 3. Okay. So question is, you can't do the division. Actual division you are not allowed to do. Just you need to check whether it's a terminating decimal or not. Second point is you have to represent this in the decimal form. Okay, that's the question. Represent it in decimal form. Now look at this question. What is its denominator? Is the denominator in the form of 2 to the power m into 5 to the power n? So 2
Yes.
square into 5 cube is in 2 to the power m into 5 to the power n form. Therefore, 31 divided by 2 square into 5 cube is a terminating decimal. Okay. Now we need to express this as a decimal, and we are not allowed to do actual division. Now what you need to look here is denominator has 2 and 5. So when you multiply 2 into 5, what do you get? You get 2 into 5 is 10,
10.
right? But here you have 2 square and 5 cube. So it would be nice if both the power are equal, in the sense 2 cube and 5 cube comes. If both are equal, what you can do? You can easily do 10 to the power cube, 10 to the power 3, right? That makes more sense. So division will be faster, or you are not allowed to do actual division. So what you need to do is 31 divided by 2 square into 5 cube, multiply and divide by 2. What do you get then? 62 divided by 2 cube into 5 cube. So now I have both 2 and 5 having the same power. This will give me 62 divided by 10 whole cube, which is 62 by 1000, which is 0.062 as the answer. 17 divided by 625. So take denominator, try to express denominator in the form of 2 to the power m into 5 to the power n. So 625 is actually 25 into 25, which is 25 into 25. We all know that it is going to be 5 square into 5 square, which is 5 to the power 4. So can I represent it as 2 to the power 0 into 5 to the power 4?
Yes.
So 625 becomes 2 to the power 0 into 5 to the power 4. Therefore, 17 divided by 625 is a terminating decimal. Okay. Write this in the form 2 to the power m into 5 to the power n. You have 17 divided by 2 to the power 0 into 5 to the power 4. So what should I do? Tell me.
Into 16 by 16.
Into 16 by 16. That's all. So I'll do 17 into 2 to the power 4 divided by 2 to the power 4 into 5 to the power 4. Just because I want 2 to the power 4 in the denominator. So I'm getting 17 into 16 would be 272. Okay, 272 divided by, this is 10 to the power 4.
272.
Yes, so 272 divided by 1 followed by 4 zeros. What would be your final answer?
0.0272.
That's all. Next is 121 divided by 2 to the power 3 into 3 to the power 2 into 7 to the power 5. 7 is coming. Then what will happen? Are we having a terminating decimal now?
Non-terminating.
Non-terminating, ma'am.
Yes, it's a non-terminating decimal because 2 to the power 3 into 3 square into 7 to the power 5 is not in the form of 2 to the power m into 5 to the power n. Hence, 121 by 2 cube into 3 square into 7 to the power 5 is a non-terminating is a non-terminating repeating decimal. Next is 66 divided by 180. So take the denominator and try to factorize it. So when I take 180, 2 times 45, then comes 5 times 9, 33. So 180 I will be expressing as 2 to the power 2 into 5 to the power 1 into 3 square. So this is also,
Yeah,
Ma'am, that's
non-terminating.
non-terminating.
yes. So because not in the form of 2 to the power m into 5 to the power n, hence 66 by 180 is a non-terminating repeating decimal. Next question is the decimal expansion of the rational number 43 divided by 2 to the power 4 into 5 to the power 3 will terminate after how many places of decimal? Look at the denominator.
5.
In the
So into
5
5
is
by
less. Yes, because if you look at the denominator 2 to the power 4 and 5 to the power 3, I told you we have to have m and n equal. Only then division will be faster. So what will you do here? 43 into 5 divided by 2 to the power 4 into 5 cube into 5. This will give you 43 into 5. Please multiply. You will get 250 divided by 2 to the power 4 into 5 to the power 4, which is going to be 215 by 10 whole to the power 4, right? 10 to the power 4. So this will give you 1 followed by 4 zeros. So when will it terminate? After how many decimal places it will terminate?
4 decimal.
Yes. So it will terminate after 4 places of decimal. Okay. You will be given a decimal number and you have to express it in a rational number format or in the p by q format. So let us take one simple example. So the question is express it in the simplest form. So I have 0.66 is recurring. Represent this rational number in simplest form. That's the question. So this is, you take x as 0.666. I mean, like that, it will repeat, right? 6 is repeating. And that is the reason on top of 6, you are writing a dash. Now, how many digits are repeating here? Look at the number and tell me.
1.
Only one digit, only 6 is repeating. So when 1 digits are repeating, you multiply with 10. When 2 digits are repeating, say if the number was 62 and these 2 numbers are repeating, then you multiply the number by 100. If 3 digits are repeating, multiply by 1000. Now here only 1 digit is repeating, so you need to multiply it with 10. So 10x will become what? What will 10x? What will 10x become?
6.6 bar.
6.6 bar. Maybe I'll write like this. Now, what I want to do is, let me give this as equation number 1, this as equation number 2. Subtract 1 minus 2, that you will get 10x minus 6.6 dash and x, x is equal to 0.6 dash. When you subtract, you get 9x and this side you get just 6 because the repeating 6 is from this and from this. Both will get deducted, right? Both will get cancelled out, or both will become 0. So 9x equal to 6. So what is x? 6 by 9. Put it in the simplified form. So what is the simplified form?
2 by 3.
2 by 3. Next question is 0.16, where 6 is recurring or 6 is repeating. X is equal to 0.16, where 6 is repeating. Now, how many digits are repeating here?
1.
1. So what do you need to multiply it with?
10.
10. So 10x equal to
1.6 bar.
1.6 bar. Okay. So here, again, I'll put this as 1, this as 2. So 1 minus 2, you will get 10x equal to 1.6 bar. And here it is going to be x is equal to 0.16, right? So what I'll do is, instead of putting dash here I'll put a dash. 9x equal to this 6 and this 6 will become 0. 6 minus 1 is 5, 1.5, right? But here there is a problem. We are getting decimal point number on the right hand side. We are not supposed to have a decimal point number, right? When you are expressing in the simplest form, or when you are expressing a rational number, you can't have a decimal point number. P by Q form, where P and Q are integers. That's what we have learned. A rational number has to be of the form P by Q, where P and Q are integers. But here 1.5 is a decimal point number. It's not an integer. So what will you do? Multiply both sides by 10. What do you get? Multiply both sides by 10. What do you get then?
Ma'am, why 10?
Why 10? Because how many
Okay,
digits
to get
are
the
coming?
decimal side to the right first.
Yes, I don't want
Okay.
any decimal point on the right hand side. So 50, that 0, I don't care. Okay, I really don't care about the zeros. But if there is a non-zero number, I have to bring it to the left hand side before the decimal point. So
Okay,
here
ma'am.
only one digit is there, that is after the one non-zero is there, which is after the decimal point. So I am multiplying by 10.
Okay, ma'am.
So this becomes 90x is equal to 1.5 into 10 is 15. So what is x? X is 15
1
by
by 6.
which is 1 by 6. So the simplest form is 1 by 6. The approach is how many digits are repeated. See, in this case, 1 and 6 comes after the decimal point, but only 6 is repeated. What does this number means? 0.1666666, right? This is what this number means. So only one digit is repeated. So when one digit is repeated, you just multiply it with 10. 0.254, where 54 is repeated. 0.254, where 54 is repeated. X is equal to 0.254. With what, which number I should multiply? Should I multiply with 10?
100.
100. Very good. Why? Why should I multiply with 100?
Ma'am, because there are, ma'am, in the bar is for 2 digits. So
Yes,
2 digits equals to
2
100.
digits are repeated, right? 2 digits keeping on repeated. So I am multiplying it with 100. So 100x is equal to 25.4. Again, 54 repeated. So this is as good as writing 0.25454. Okay. So this, when I am multiplying, what do I get? 2 digits move to the left side. And what is left? 454. Understood? So this you have to be clear with. When you multiply, you have to see what you are multiplying with. Now subtract 100x minus x is equal to 25.454 repeated minus 0.254 repeated. Okay, you can write it in vertically also. I have just written it horizontally. So this gives me 100x minus x is 99x. Now 25, okay, let me write it. This will not help. So 25.454 and this is going to be 0.254. Okay, now these two are recurring. Now when you subtract, you get 0.225. Now do you see a decimal point number here? I am getting a decimal point number, right? On the right hand side, I'm getting a decimal
Yes,
point number.
ma'am.
So what should I do?
Multiply both sides with
Multiplied by
10.
100.
Is it 100?
No.
How many non-zero digits are there after the decimal
Yes,
point?
ma'am, 10. It's 10.
10. Yes. So multiply both sides by 10. So you get 990x is equal to 252. X is 252 by 990. Now divide it 3, 8, and you have 4 divided by 3, 3, 0. Okay, again you can divide. So this divide, I'll get 42 divided by 165.
Yes, ma'am.
Right?
Yes, ma'am.
Yes, again you can divide over.
14 by 55.
14 by 55, right?
40. Okay,
Yes.
yeah, 14 by 55. So again 3, right? Again dividing by 3, you get 14 by. So 14 by 55 is the simplest form in which you will represent 0.254.